Okay, so here is our specific term formula for a geometric sequence. And you notice how the ones are both circled here. They correspond to each other, okay? So this formula is great if you know the first term. In this example that we're about to do, we have the third and the sixth terms. We don't know the first term, and we're trying to find the 23rd term. So in that case, it might be more useful to use this modified version of the geometric specific term formula, where I have m's here instead of ones, and that means I can use any term in this position. Okay, so let's try it out here. So this tells us that this is geometric. That's important because then I know to use this formula. Okay, and what I'm going to do first is find the ratio. So I'm going to plug the two known terms in these positions. So I could put a sub 3 in either one of these slots. I like to put the higher term number in the first slot and the lower term number in the second slot because I've got to subtract, it's n minus m. So here it's going to be 6 minus 3. I'd rather just have that exponent be positive, so that's why I like to put the higher one there. And then I don't have to deal with a negative exponent. Okay? All right, and then I'll plug in the actual value of those two terms. So I've got negative 160 for a sub 6, and I've got 20 for a sub 3. And then, hey, 6 minus 3 is 3. And now I'm solving this for r. Okay, you could plug in the negative 160 and the 20 right from the beginning, but then I find people use those numbers up here, and you have to use the term number. So that's why I like to do it in two separate steps like that. Okay, so next, I am going to take the cube root at some point, but before I do that, I'm going to divide by 20. Okay, and this will give me negative 8 over here equals r to the third. Now I'm going to take the cube root of both sides. Okay, so on the right side, that's just going to give me r. On the left, I'm going to take the cube root of negative 8. And you might not need a calculator for this, but I'm going to get a calculator anyways to show you how to do a cube root on these types of calculators. So negative 2 times negative 2 times negative 2 would be negative 8, right? So this should come out to negative 2. You can do this by hitting this math button on the left-hand side of a graphing calculator, and then there's a cube root function right there. If you needed to do like a fourth root or fifth root or something, you could use the x root one. So I'd do that, and then when I hit negative, don't hit this minus button here. You want to use the negative button that's right below the 3 here, and the one in parentheses, because we're not subtracting, we're just saying negative 8. Okay, and then it comes out to negative 2. You could also take negative 8 and raise it to the 1/3, like so, and that works as well. Okay, so anyways, our ratio is negative 2. Okay, so now that we got that, we can move on to the next part. So now we're going to find a sub 23. We're going back to the same formula, and I'm going to plug in a sub 23 in this slot so that I've already got that isolated. Okay. And then on the right side, I have to plug in one of my other terms here. Sorry about the focusing there. I'm gonna put in either of my known terms in this slot. It doesn't matter which one. Since I put in a sub 3 for a sub m over here, I'll stick with that. Okay, and then my ratio I already figured out was negative 2. That's why you have to find the ratio first, because you're going to need it over here. Okay, and then the subtraction, I'll have 23 minus 3. Okay, and then I can plug in the actual value of a sub 3. I don't know a sub 23 yet. That's what I'm trying to figure out. But I know a sub 3 was 20. Okay, and then I can simplify the exponent there to 20. And now I'm just going to do this on my calculator. So I'm starting with this, right? Do exponent before multiplication. We got to follow PEMDAS. And you want to put the negative 2 in parentheses so that your calculator doesn't raise to the 20th first and then take the opposite of that. We want to take the quantity negative 2 to the 20th. Okay, so I've got that. And then multiply by 20. Okay, and there we go. There is the 23rd term of that geometric sequence. Okay, let's try another one. This is going to be a similar problem, just some new numbers here. I'll use my black pen to make it a little easier to see here. Okay, so I'm going to put the higher term number in the first slot, so I'll put a sub 5 there and a sub 2 here, and then 5 minus 2 then would be the exponent, okay? And then let's see, let's plug in the value of both of these terms. A sub 5 is negative 768, a sub 2 is 12, 5 minus 2 is 3, okay? Next I'll divide by 12 to isolate r to the third. That gives me negative 64. Okay, and then I'll take the cube root of both sides. And that's going to come out to negative 4 there, right? So negative 4 is the ratio. And now I can move on to phase 2 over here. So I'm going to put a sub 41 over here, so that's isolated. A sub m, let's see, I had a sub 2 over there before. I'll stick with that. I'll use the actual ratio that I found on the left side here, negative 4. And then my exponent would be 41 minus 2. Okay? Next, I'm going to substitute in the value of a sub 2, which is 12. And I'll simplify the exponent. And then it's PEMDAS time, right? So I'm doing the exponent next. So let's see, negative 4 raised to the 39th. Okay, this is in scientific notation, so I'm not going to actually bother writing this down on the paper yet. First, I'm going to multiply by 12. Okay, so this is not just negative 3.63, something like that, because you get that E24, which means times 10 to the 24th. So that's super important. So I'm going to call this negative 3.63 roughly times 10 to the 24th. That means that decimal is moved 24 spots to the right, so it's a very large number. So you gotta always be on the lookout for scientific notation on your calculator, and you want to represent that when you write your answer. Okay? All right, that's it for the section. See you next time.